Good morning, students. Last time from Thermodynamics, we completed what is called thermochemical equation. Then we completed enthalpy of formation, enthalpy of combustion, similarly bond enthalpy and enthalpy of reaction from bond enthalpy. Today we want to start very important point from thermodynamics, that is Hess law of constant heat summation. So thermodynamics from this very important point to the point of board examination and to the point of entrance exam also. Hess law of constant heat summation, Hess law of constant heat summation, Okay, as you know that Hess, name of the scientist who given the law of constant heat summation, that's why it is called as Hess law of constant heat summation. For example, you know that first of all we write the general reaction. You know A gives D. A is called reactant, D is called product. The enthalpy change, standard enthalpy change for this reaction, suppose it is 100 kilojoule. For your understanding, suppose same reaction takes place in two steps. That is, first step A gives B, that is called standard enthalpy of first reaction, that is equal to, suppose it is 70 kilojoule. And in the second step B react to give D. Enthalpy change for this second reaction is equal to 30 kilojoule. Then sum of these two reactions B get cancelled on the left hand side and right hand side of the equation. Reaction is A gives D. So sum of these two enthalpies, that is enthalpy change of reaction, standard enthalpy change of reaction is equal to 100 kilojoule. So this is the general example. What we can say? We can say that enthalpy change for a chemical reaction is same whether reaction is carried out in one step or in several steps. That is called as Hess law of constant heat summation. What is Hess law of constant heat summation? Enthalpy change in a chemical reaction is same whether reaction is carried out in one step or in two steps. That is called as Hess law of constant heat summation. Or we can write the statement as like this. For this Hess law of constant heat summation, the statement is written as like this. Overall enthalpy change for the reaction, overall enthalpy change for the reaction, enthalpy change for the reaction, overall enthalpy change for the reaction is equal to sum of enthalpy changes, is equal to sum of enthalpy changes, sum of enthalpy changes, sum of enthalpy changes of individual steps in the reaction, of individual steps in the reaction, that is called as That is also called as or another statement of Hess law of constant heat summation. So we can write any statement. First statement, enthalpy change for a chemical reaction is same whether reaction is carried out in one step or in several steps, or overall enthalpy change for the reaction is equal to sum of enthalpy changes of individual steps in the reaction. That is called as Hess law of constant heat summation. Okay, we want to know another example. For example, you know that before going to applications of Hess law of constant heat summation, consider the synthesis of ammonia in two steps. First step is, that is, you know that two molecules of hydrogen gas plus two molecules of nitrogen gas. It gives, what it gives? It gives N2H4. Sorry, one molecule of nitrogen gas. It gives N2H4. That is called hydrazine. That is called hydrazine. So, enthalpy change for this first reaction is plus 954 kilojoule. Standard enthalpy change for this reaction is plus 954 kilojoule. And second step, that is, this hydrazine further reacts with N2H4 plus H2 gas. It gives NH3 gas. Here, to balance the reaction, we write 2. So, the enthalpy change for this second reaction is minus 187.6 kilojoule. Minus 187.6 kilojoule. Here, enthalpy change for first reaction, this is the enthalpy change for second reaction, that is minus 187.6 kilojoule. You know that when we add these two reactions, hydrazine on the left hand side and right hand side get cancelled. Here we can write, that is N2 gas plus, that is 2H2 and this H2, that is 3H2 gas. It gives 2NH3 gas. And you know that the enthalpy change or when we add these two values, we get the standard enthalpy of this reaction, that is minus 92.2 kilojoule. Minus 92.2 kilojoule. So this reaction is also the example of Hess law of constant heat summation. Okay. Now we want to know what are the applications of Hess law. So, application of Hess law of constant heat summation. You know, by using Hess law, we can add, multiply, subtract thermochemical equations like algebraic equations. You know what is called thermochemical equation? Yesterday we completed the equation in which the standard enthalpy change, that is the delta H, value of delta H is given on the right hand side of equation, that is called as thermochemical equation. So here the application of Hess law of constant heat summation is that is to calculate the enthalpy change for the reaction whose enthalpies cannot be found experimentally. Whose enthalpies cannot be found experimentally. What is the first important application? First important application is that Hess law is useful to calculate the enthalpy change of those reactions whose value cannot be found experimentally. That is the important application. And by using Hess law, we can add, subtract, multiply and divide the thermochemical equations. For example, you know that here enthalpy of formation of CO, carbon monoxide cannot be found experimentally. We cannot find experimentally, So by the use of Hess law, we can find the enthalpy change for formation of carbon monoxide gas. For example, what will be the equation for formation of carbon monoxide? Yesterday you know that we completed thermochemical equation. What we want to prepare? We want to prepare carbon monoxide gas. You know that carbon monoxide is obtained by the reaction between carbon and oxygen, which is in its standard state. For example, the standard state of carbon is graphite plus oxygen, it is the gas, is its standard state. To balance the reaction here, we want to write 1/2. So, what is the value of standard enthalpy change for this reaction? It is very difficult to find experimentally. By using Hess law, we can find the value of enthalpy change for this reaction. You know why we cannot find experimentally the value of formation of carbon monoxide gas? Because some of the carbon get oxidized to carbon dioxide. That's why we can find out the enthalpy of this reaction from the enthalpies whose enthalpy. So the first reaction is carbon graphite plus oxygen gas, it gives CO2 gas. The enthalpy change for this reaction is known and it is found to be minus 393.5 kilojoule. The second reaction is carbon monoxide gas plus 1/2 O2 gas, it gives CO2 gas. Its standard enthalpy change is minus 283 kilojoule. Now, from these two reactions, we can find the enthalpy change of formation of carbon monoxide. How? You know that here we want to reverse equation second. Why we want to reverse equation second? Because in this reaction, carbon monoxide gas is reactant, here it is product. That's why we want to reverse this equation and we want to add equation 1 because here carbon graphite are the reactant. So what is the operation to obtain this equation whose enthalpy change is to be found out? The operation is that we want to reverse equation second and add equation 1. So what is the operation? Reverse equation 2 plus equation 1. So you know that when we reverse the equation second, what equation we get? That is CO2 gas, it gives carbon monoxide gas plus 1/2 O2 gas. You know that this value is minus 23 kilojoule for formation of carbon dioxide. But when we reverse it, last time we completed, whenever thermochemical equations are reversed, the value of delta H is also reversed. So the value of delta H for this reaction is equal to plus 83 kilojoule. Now we want to add equation number 1. That means we want to write equation number as it is. That is carbon graphite plus one half O2 gas. It gives, what it gives? Sorry, carbon graphite plus O2 gas here. Sorry, carbon graphite plus O2 gas. It gives, what it gives? It gives CO2 gas. And you know that when we add this, so the value remains as it is, that is minus the standard enthalpy change of this reaction minus 393.5 kilojoule. So here when we cancel carbon dioxide gas, what remains? Carbon graphite, standard state of graphite, plus you know that 1 half O2 and 1 O2, that means 1 half O2 remains here. 1 half O2 and O2, 1 O2 minus half O2, that is half O2, and this carbon monoxide gas. So from these two equations we get again this equation. So when we done the operation plus 293 and minus 293.5 kilojoule, that we get the value minus 110.5 kilojoule, minus 110.5 kilojoule. So that is the application of Hess law of constant heat summation. You know that what is the application of Hess law of constant heat summation? The important application of Hess law of constant heat summation is that formation of carbon monoxide gas, we cannot find experimentally the value of delta H, standard enthalpy change, for this reaction. So how will we find it? We will find it by using Hess law of constant heat summation. You know that we written the two equations whose delta H, standard enthalpy change, values are known. So when we reverse this equation second and when we add equation 1, then again we get this equation and we done the same operation on the values of delta H, and we can say that now the standard enthalpy of formation of carbon monoxide gas is 110.5 kilojoule, isn't it? Okay. Now we want to solve one important problem based on Hess law of constant heat summation. So pay attention here. Just now we completed what is the statement of Hess law of constant heat summation and what is the application of Hess law of constant heat summation. You know that we want to solve one problem based on Hess law of constant heat summation. What is the problem? The standard molar enthalpy of combustion of glucose. The standard enthalpy change, molar enthalpy change for combustion of glucose. You know, all of you know what is the formula of glucose? C6H12O6. Okay, the standard molar enthalpy change for combustion of glucose C6H12O6 is minus 2815 8 kilojoule per mole. 8 kilojoule per mole. So the standard enthalpy of formation of the standard enthalpy of the standard enthalpy of formation of H2O liquid, carbon dioxide gas, CO2 gas, that is minus 2 285.8 minus 285.8 and minus 393.5 kilojoule per mole respectively. Kilojoule per mole respectively. So calculate the standard enthalpy of formation of glucose. So calculate the standard enthalpy of formation of glucose. So the important application of Hessenhoff constant heat summation is that just now we completed. We can multiply, add, subtract or divide the thermochemical equation as like algebraic equations. Here, by using the application of Hessenhoff constant heat summation, we want to find out the standard enthalpy of formation. We want to calculate the standard enthalpy of formation of glucose. You know that enthalpy of combustion of glucose is given. Similarly, enthalpy of formation of H2 and CO2 are given. So first of all, we want to write from this data the equation whose enthalpy is to be found out and the thermochemical equation whose enthalpy change values are given. So first of all, the equation for that is the standard molar enthalpy change for combustion of glucose is given. We want to write the combustion of glucose, then we want to write the formation of H2 and CO2. So pay attention carefully. Here combustion means yesterday we completed. Before this we studied the definitions of enthalpy of combustion, enthalpy of formation. So glucose, you know molecular formula C6H12O6. What is the standard state of glucose? It is solid. You know that combustion means what? Combustion means reaction with oxygen. Reaction with oxygen is called combustion reaction. Now, in the reactant, carbon, hydrogen and oxygen are present. You know products are here. Carbon dioxide gas plus H2O liquid. So we want to balance this equation. Here there are 6 carbon. We want to balance this carbon by writing here 6. You know that how many hydrogens are there? 12. So we want to write here 6H2, 6 into 2, that is equal to 12 hydrogen. There are how many oxygens? 6 and 8. Here 12 plus 6, 18. Means here we want to write 6. Now 6 into 2, 12 plus 6, that is equal to 18. 6 into 2, 12 plus 6, that is equal to 18. You know that this is the balanced reaction for combustion of glucose. So the standard enthalpy change of this reaction is given. Delta H of this reaction is given in the problem. It is minus 2815.8 kilojoule. Okay. Now second equation we want to write, that is formation of water. You know that water consists of which elements? Hydrogen and oxygen. Molecular formula of water H2O. What is the standard state of water? Liquid. As it contains hydrogen and oxygen, definitely the reaction takes place between hydrogen and oxygen. Gas, here it is gas, to balance the reaction. Okay, now third reaction, formation of carbon dioxide. What is the standard state of carbon? Graphite. Standard state of carbon is graphite plus O2 gas. It gives CO2 gas. Standard enthalpy change for this third reaction is minus 393.5 kilojoule. You know that here from the given data we written these three equations. What you have to calculate? We want to calculate the standard enthalpy of formation of glucose. Standard enthalpy of formation of glucose. So, glucose molecular formula is C6H12O6. What is the standard state of glucose? It is solid. Now, here in problem it is given or it is asked to show the enthalpy change for this reaction. Now, there are 6 carbons, so we write here 6 carbon, standard state of carbon, graphite, plus that is 12 hydrogen, that means 6H2 gas, plus there are 6 oxygen, 3 O2 gas. So that is the equation whose enthalpy is to be found out. You know that just now we completed Hess law of concentrated summation. We written all the thermochemical equations from the data given in the problem. First equation, combustion of glucose. Second equation, formation of water. Third equation, formation of carbon dioxide gas. And in the problem it is given, we want to find out from that problem the enthalpy of formation of glucose. So when we check these three equations, or how we find this equation from these three equations, you know that what operation we want to do to obtain this equation whose enthalpy change is to be found out. So the operation is as like this, that is, if we check the first equation, glucose here it is reactant, here it is product. So in this case we want to reverse equation 1. Reverse equation 1. Okay. If you check the second equation, then you know that here H2 gas is reactant, here also H2 gas is reactant, but here coefficient for H2 is 6, but here coefficient is 1. That's why we want to balance second equation by 6, that is plus equation 2 multiplied by 6. Now third equation, you know that here carbon, graphite, single atom of carbon, here there are 6 atoms of carbon. Again we want to multiply equation number 3 by 6. Equation 3 into 6. So first of all we want to reverse this equation. Which equation? First equation. When we reverse this equation, what will be the equation? The equation will be 6CO2 gas plus 6H2 liquid. 6CO2 gas plus 6H2O liquid. Okay. Then what is the remaining, or what is the product? That is C6H12O6 solid. C6H12O6 solid plus that is 6O2 gas. 6O2 gas. You know that whenever thermochemical equations are reversed, the value of delta H is also reversed. So it is not minus now, it becomes plus. multiply second equation by 6H2 gas plus 6 into 1 half, that will becomes 3O2 gas, and here 6H2 liquid. We want to multiply this value, that is by 6 multiplied by 6. Okay, again we want to multiply equation 3 by 6. 6 graphite plus 6 O2 gas, it gives 6 CO2 gas. Again we multiply this value of delta H by 6. So here it is important to know that when we add these three equations, what happens? 6 CO2 gas get cancel. 6H2 liquid also get cancel. What is remaining? Carbon, 6 carbon graphite plus 6H2 gas plus, you know that 6O2 gas cancel. Here 3O2 remains, 3O2 gas plus product is here 6C6H12O6 solid. So value of delta H for this reaction becomes, so you know that from these three equations we again get the equation whose enthalpy is to be find out. So same operation is done on the value of delta H. So delta H, standard enthalpy change for this reaction is equal to, that is 2815.8 plus 6 into minus 285.8, 6 into minus 285.8 plus 6 into minus 393.5. You know that when you solve this, we get the value of enthalpy change for the formation of glucose, and it is found to be minus 1260 kilojoule. So that is the final answer of this problem. So that is the from the statement of Hess law of constant rate summation and applications of Hess law of constant rate summation, we can solve a number of examples of such types.